To my channel. Here we are going to be working on plane figures with equal area, and I have some special questions here that I'm going to use in teaching this particular topic in technical drawing. The first question that I'll be taking here says that draw a regular pentagon of sides 45 millimeters, construct an isosceles triangle of the same area. I'll read the question again. It says, draw a regular pentagon of sides 45 millimeters, construct an isosceles triangle of the same area. So we are going to work on this. The first thing that we are going to do is to construct a regular pentagon of side 45 millimeters. So let us start and do that. So I'm going to do the construction this way. I'll be making use of my protractor to make the exterior angle of the pentagon. So I'm going to draw a horizontal line here like this, okay? Then on this line, I'm going to take a measurement of 45 millimeters, as we are told that the length of side of the pentagon is 45 millimeters. So this is 0, and then here I have 45. So this is 45 millimeters. I'm going to label this point, and I'll call this point, I'll call it, this is point A here, and I'll call this point, I'll call it point B. They are 45 millimeters apart. Now, the exterior angle of a regular pentagon is 72 degrees. The exterior angle of a regular pentagon is 72 degrees. So how do I get that? So there is a formula that you can use to determine the exterior angle of a regular polygon, and that is 360 divided by number of sides. So if the number of sides of the polygon is 5, as we are dealing with a pentagon here, so if you divide 360 by 5, and that will give you 72 degrees. So we have the exterior angle to be 72 degrees. So you take your protractor as I have it here. So set the center point at point A and this horizontal line on this line, okay? So this is what I'm saying. So just set the center point at point A like this, and the horizontal line on the line AB that we just drew. Then this is 70 and then 72 degrees. So here we have 72 degrees here. So put a mark on the paper. Then bring it to point B here also. So set it at point B. Okay. Then we are going to read it down here. So this is 70, and then I have 72 degrees here. So this is 72 degrees. So what we have to do next is that we are going to draw a line from point B passing through the mark that we put on the paper, and it goes like this. Okay, we have this, and then I'm going to draw from here also, so passing through the mark that we put on the paper. So we have it like this. So the next thing that we are going to do is that we are going to take a measurement of 45 millimeters, which is the length of side of the regular pentagon. So from this point B here, take a measurement of 45 millimeters. This is 45 millimeters, and also from point A here, take 45 millimeters up. So this is 45 millimeters. So I'm going to call this point, I'll call it point C. So this is point C here, and this point here, I will call it point E. So, okay. So the next thing that we are going to do is that we are going to set the protractor at this point, point E here. So set the protractor at point E, and then so make sure the line, this line on the protractor is on line AE. So reach 72 degrees from this side. So this is 70. Then I have this to be 72 degrees. So this is 70, 71, 72. So this is 72 degrees here. Just put a mark on the paper, and then turn it here to point C. And then so make sure the line is on line BC as we have it here. Okay. So now, so we have to read the angle. So that is angle 72 degrees. So read from this side, this is 70, and here we have what we have this to be. So this is 72 degree here. So this is 70. So 70. So I'm trying to see it clearly. So this is 72 degrees. So we have 72 degrees here. So what we are going to do now is that we are going to draw a line. So from this point E, so passing through this point that we put here on the paper, so it goes like this. then I will draw from here. So I will draw from this point, okay, so from point C, so passing through the point that I will put on the paper. So here we have a regular pentagon. So this point here, I will call it point D. So this is point D here, okay. So we have a regular pentagon ABCDE, ABCDE with length 45 millimeters. So now we are told that we should construct an isosceles triangle whose area is equal to the area of this pentagon. So how can we do that? So I will need to extend this line a bit to this side, extend to this side, and also extend this line, extend it a bit to this side. Then we are going to join this point A together with point D, and point B here we're going together with point D. So this is what I mean. So draw a line from point A here and join it together with point D, okay, at the apex of the pentagon. Then also draw a line from point B, so draw it to point D on the pentagon as we have it here. Then the next thing that we are going to do is that, so just look at what I'm going to do next. So what we are to do next is that we are going to set a set square on line AD. Set the set square on line AD like this, okay. Set on line AD and put the ruler under the set square. So what we want to do is that we want to draw a line that will be parallel to this line AD at point E. So set the set square like this with the support of the ruler as I set it here. Then shift the set square to point E at this point. So having drawn this line parallel to line AD, so I'm going to call this point, I will call it point F here. So this point, so where this line that we drew parallel to line AD touches this line, so I will call it point F. This is point F here. And then, so as I said, so let us show here that this line, so this line here, so it's parallel to line AD. So it's parallel to line AD. Let's take note of that. Then the next thing that we are going to do is that we are going to set the set square on line BD. So set the set square on line BD like this, okay. Set the set square on line BD, and then to now shift the set square. So we shift it to point C here, okay. Don't forget that we have to support the set square with the ruler, okay. So now, so getting to point C, we draw a line from C to touch this line, okay. So wherever it touches this line, so let's call it, so we call it, this is point G here. So we have this point to the point G. All right, so having done that, we know that this line CG is parallel to line BD. So I'm going to call this point, I'm going to show here that this line is parallel to this line by drawing this arrow, okay. So having done that, the next thing that we are going to do is that we are going to bring out the isosceles triangle that we asked to draw, which should be equal in area to this regular pentagon ABCDE. Okay, so to do that, okay, so what I'm going to do is that we are connecting this point F with point D here, and we are connecting point G with point D, and that isosceles triangle will come out. So this is it. So draw a line from point F here, so join it together with point D, so it goes like this, and then so you draw a line from point G here and join it together with point D, okay. So looking at what we have here, so this is the required isosceles triangle. So the required isosceles triangle is triangle FDG. FDG is the required isosceles triangles. As simple as I've done it here. So all you have to do is to practice. When you practice this, you become a master at this. This is how to draw an isosceles triangle to a given pentagon ABCDE. And we have it as an isosceles triangle because the given figure is a regular pentagon. That's why the figure that we asked to draw that be equal in area to this pentagon is an isosceles triangle. Thank you, keep on practicing, and God bless you.